All right, so this video should be a review of things that you've learned before about slope. So I just want to remind you of a few different formulas and maybe some notation that you haven't seen before. Okay, so the first thing we want to do is talk about how do we find slope from a graph. And the phrase that you are probably most familiar with is rise over run. Now, I am going to say this phrase, but I really want you to remember something a little bit different that we're going to use later on, and that is that slope from a graph is the vertical change over the horizontal change. And this is another word for slope is rate. So that's gonna come in handy later on. So just remember that we're talking about a rate of change or the pattern that we've seen most regularly. Okay, so I'm actually gonna do these in the opposite order. So let me slide these over. You do need to have these graphs in your notes, and you need to have these points specifically or you're not gonna understand what we're doing. All right, so the first thing I wanna show you, when we count slope, we're gonna count from left to right. So think about if you were to write your name on this line, the first point, like wherever you would start your name, that's where you're gonna start counting. And this line goes, if we're starting there, this line is going to have a negative slope because it's decreasing. So I'm just gonna make a note of that to myself. This is negative. And so my goal is to count from that first point to this second point. And I want to count rise over run. So first I'm going to go vertical. And if I count this, I'm going to go 1, 2, 3, 4. It looks like I'm going down 4. So that is a vertical change of -4. And then horizontally, 1, 2, 3, 4, 5. I'm going to go a positive change of 5 in the horizontal direction. So when I write my slope here, the final slope for this question is going to be -4 over 5. Okay, if I do that on this other one, so notice this second graph, a few things about it. First, the second graph does not have any points that are marked. Second, I notice the graph is counting by 2s. So I'm going to start by marking the points that go through the corners of boxes. So for instance, I see this point. You might see a lot of them. And let's say that this is the next one that I see. Okay, so I'm going to make my vertical change first. This is a positive slope. So where I put the P, that's going to tell me that's where I'm starting. I'm going to count the vertical change first. Notice that when I'm counting, though, this is not really a jump of 1. And I'm going to zoom in so you all can see this. That's not a jump of 1 right there that I'm really making. That's a jump of 2 because of what the graph is counting by. So this is really up 2, 4, 6, 8. So that has a vertical change of +8. And then horizontally, again, this is counting by 2s. This has a horizontal change of 4. So when I go to write my slope, this is going to be 8 over 4. And if you can simplify it, you should, because obviously the simpler that we can see the problem, the better when we go to use it later on. So this really has a slope of 2 over 1 or just 2 is probably the best way to write that, a slope of 2. Okay, real quickly, just the last thing about graphs, I just want you to have in your notes what the different types of slope are. So for instance, this first one is a positive slope because it's going up if you wrote something on top of it or if you're looking at the right side. The next one is a negative slope because it's going down, which we've talked about. These are the two that people tend to get the most confused. Completely horizontal is a slope of 0. And then straight up and down is a slope that we call undefined. And it's because this is not actually a function, because this is not a function, that's why we call this an undefined slope, because it can't have a slope if it's not a function. So make sure that you have those 4 written down. All right, so from a table, slope still means the same thing. Remember on the previous slide, I told you that slope was the vertical over the horizontal change. Well, vertical is our y variable. So from a table, we're going to call this the change in y. And this little triangle right here is a Greek letter delta. It means change. So you might want to write that in your notes in the actual words, change in y over the change in x. So we're going to do these 2 examples real quick. This first one, if I find the change in y, I'm just going to be looking here. This change every time looks like it's going by, up 4. There we go. That's better. Up 4. Up 4. Okay, so this is the same every time. And on the x side, it looks like my change is increasing by 2. And that seems to continue throughout the table. So when I go to write my slope, it's the y over the x. So the slope is 4 over 2, or I can just simplify that to 2. And remember, because this change is constant, if you just want to make a note to yourself, this would be a linear table that we're looking at here. All right, now let's look at this other one. What I want to show you on this other one, so I want you to copy this down and then pause the video and see if you can find the rates of change in this table. Okay, so these are the changes I got. And you might look at that and say, oh no, that's not linear. It's changing by different things every time. But remember that slope is y over x. So if I look at each one of these sections individually, and I do y over x, that's negative 22 over negative 2, which gives me a slope of 11. All right, now if I look at this next section, and I do that same, check the same rate, negative 33 over negative 3, well, guess what? That's still 11. You're going to see that happens each time. If I check here, it's the same thing, negative 22 over negative, oh, and these are not negative 2. Those should all be positive values on this side. Sorry. This should say positive 2, positive 3, positive 2, positive 1, positive, positive. So this should be negative 11, and this should also be negative 11. So this is actually linear, even though the pattern doesn't appear to be, the rate of change is linear. All right, and then lastly for this video, we're going to talk about finding the slope from 2 points. And this should be a formula that you're familiar with, but it's probably been a while since you've seen it. It's the same concept. The slope on the top is always the change in y. So instead of saying the vertical change or the change in y, we have an actual formula, and that is y2 minus y1. And then the bottom is the change in x, x2 minus x1. All right, so the 2's and the 1's tell you which point you're talking about. So in this first example, this is x and y, x1, y1, because this is talking about the x from the first point and the y from the first point, right? This is a point. And the second one is going to be x2, y2. For some of you, labeling that is going to be very helpful. All right, so now we're just going to set up our formula. Our slope is y2 minus y1. Notice that I put minus and then the value negative 5. And then the bottom is x2, which is negative 3, minus x1. And now you're just simplifying this. I do see when I simplify that this can become a plus sign on the top. So that's going to give me 7 over negative 11. And I can't simplify that any further, so that is the answer there, 7 over negative 11. All right, same thing on the next one. So I want you to pause the video and see if you can set up the slope for this second equation. All right, that's what I got. So again, I see this double negative sign happening, so that's changed to positive, so this is 15 over. Now on the bottom, 4 minus 4 is 0. And some of you may not remember what you're allowed to do here, but you are not allowed to divide by 0. In fact, if you type this in your calculator, it's going to give you an error message. That's because this is an example of an undefined slope. So you need to know how to simplify these and how to use these 3 formulas for class tomorrow.